So, hello everybody, and let's now have a look on the H.264 video encoder that is embedded in the STM32N6. So, why do we want to encode the video? It's quite simple because the video data in the raw form takes quite a lot of memory, and we need to compress this data in order to be able to either store it or stream it, as we are doing now during this workshop. So how does the video encoding works? So let's compare two approaches. One is the moving JPEG. So this is what we can do, for example, on our other STM32 devices, where basically each frame is encoded individually, and we can use the JPEG encoder that's embedded in some of the devices. But the resulting size is still quite big. So for each frame, we have individual encoding. And for the H.264 or any other video codec, we basically have a different kind of frames. So one of them is intra-frame. So these are again encoded individually as in the moving JPEG case, but then we have another type of frames which are interframes. So they are encoded using information from other frames. So we can have these predicted frames that basically use information from the previous frame, or even in some more complex cases, we can have bidirectional frames. So these can use information from the later frame. So this can be useful, for example, for video playback when playing a file. And so use of these interframes can help us reduce the size significantly. So we can then have a lower bandwidth, and it's suitable for broadcasting the video from camera. So let's have a look on the hardware video encoder that's inside the STM32N6. Here we have the simple diagram. So the encoder is connected to the bus matrix, so it can act as a master and access the image data. It also has this internal SRAM memory, which if we are not using the video encoder, we can use as a RAM, but if we use the video encoder, it's allocated to the video encoder. We have as well this VENcoder ready signal from the camera pipeline, so we can automatically start the encoding once we receive the image from the camera. On the software side, there are different levels. So we have some low-level drivers that are directly talking to the hardware. Then we have the encoder wrapper layer. And then finally, we have the main API that we will use in our application. And with the encoder, we support not only the H.264, but we can do as well as JPEG encoding. And of course, then we need to have some data in the RAM of the microcontroller, so the image data, input picture, output picture, and some additional data. So to summarize the features, what we can do with this peripheral, we support different kind of input pixel formats. We support either HD resolution with 30 frames per second or full HD resolution with 15 frames per second. We can do some additional image processing like cropping the picture or rotating the picture. We support profiles from 1 to 5.2. So these are standard profiles defined by the H.264 codec. And we have the low latency feature, so we can automatically start the encoding once we receive the picture from the camera.